Today we are going to start our first chapter in plus one mathematics, that is set. Set theory is developed by one of the great mathematician George Cantor. Actually this chapter is very simple, but the concept that we will develop from this chapter will use in coming chapters. Okay, so this chapter is very important. So let us start this chapter with the definition of set. Set, what is set? Set is well defined collection of objects. Well defined collection of objects. Objects can be numbers like 1, 2, 3, etc. It can be variables like x, y. It can be benches, desks, etc. But all collections are not set. In our daily life, we come across different type of collections. Collection of all numbers less than 10, collection of all rational numbers, collection of all benches in your class, collection of all boys in your class, etc. But all collections are not set. A collection is a set if it is well defined. What is the meaning of well defined? It should be unique. It should not vary from person to person. Okay, let us consider some example. Consider first example, all natural numbers less than 5. All natural numbers less than 5. What are the natural numbers less than 5? 1, 2, 3, 4. Okay, these are the natural numbers less than 5. This is unique collection. It won't vary from person to person. Let's say another example. Suppose I want to write a collection of most famous 3 cricket players. According to me, most famous three cricket players are Sachin, then Dhoni, and Kohli. Is it unique? Is it a set? It may vary from person to person, right? Because for some other person, this can be Rahul, Ganguly, right? Smith. So this collection is not a set because it depends upon person to person. Okay, I think now you understood the concept of just a collection and a set. Okay, consider some collections. You have to tell whether it is a set or not. First one, all prime numbers less than 15. Is it a set? All prime numbers less than 15 is a set because it is unique. What are the prime numbers less than 15? It is 2, 3, 5, 7, 11 and 13, which is unique. Okay, it won't vary from person to person. Okay. Now consider second one, the collection of all even integers. Collection of all even integers are 2, 4, 6, 8, then 0, -2, -4, -6, etc. which is unique, therefore it is example for set. Then collection of all most talented writers in India. Most talented writers, which depends upon person to person. Okay, so it is not an example for set. Collection of all most dangerous animals also is not a set because it also depends upon person to person. For some person, even cockroaches are dangerous animals, right? Dear students, usually capital letters are used for representing set and small letters to represent its elements. Consider one set A, and suppose a small letter A is element of the set. Then A, we can have A belongs to A, right? A belongs to A, which is denoted by the symbol A belongs to A. That is an epsilon symbol, Greek letter. Okay, for example, N. N means collection of all natural numbers. So what about 1 and then 1 belongs to N or does not belongs to? Actually 1 is a natural number, so you can write 1 belongs to N. 1 belongs to N. What about -5? -5 is not a natural number, so we can write -1 does not belongs to N. So 1 belongs to N, -5 does not belongs to N. If A is an element of capital A, we can denote by A belongs to A. Okay. I told we can use capital N for represent collection of all natural numbers. N means collection of all natural numbers. 1, 2, 3, 4, etc. Now, how to represent whole numbers? Whole numbers are represented by W or H. Whole numbers means 0, 1, 2, 3, etc. Next collection is integers. Integers are represented by Z or I. How we can represent integers, etc. -2, -1, 0, 1, 2, etc. Okay. After integers, next collection is rational numbers. Rational numbers are represented by Q. Rational number means a number of the form P by Q where P and Q are integers and Q not equal to 0. All those things you already know. Now, after rational numbers, next collection is irrational numbers. Irrational numbers are denoted by letter T. Irrational numbers. For example, for irrational numbers are √2, √3, etc. Now, rational number plus irrational number is another collection that is called real numbers. All numbers on a real line are called real numbers. That is denoted by the letter capital R. Okay. We can represent set by using two different methods. First one is roster form. Roster form or tabular form. Tabular form. And second one is set builder form. Set builder. Set builder form. Okay. First I will explain roster form. In roster form, we have to list all elements. You have to list all elements of the set separating by commas inside the curly bracket. This one is curly bracket. Suppose we want to represent all natural numbers between 5 and 10. All natural numbers between 5 and 10 by using roster form or by using tabular form. Both are same. So how we can represent? First, you represent by using capital letters. Then you will start this curly bracket. Then we have to write all elements separating by commas. So all natural numbers between 5 and 10 means we cannot include 5. You have to start with 6. 6 is the first natural number. Then 7 separating by commas. 8, 9. Then we have to close. In this way we can represent set by using roster form. We have to list all elements separating by commas inside the curly bracket. Okay. Now we can do some questions. Represent the following set by using roster form. First one, set of all integers between -3 and 4. You have to represent by using roster form. So we can start with capital letter A equal to curly bracket. Now you have to list all elements. Between means first you have to start with -2, right? -2, -1, 0, 1, 2, 3. So very simple. All you are listing all elements separating by commas inside the curly bracket. Now comes the second question. Set of all solutions of the quadratic equation x square minus 5x plus is equal to 0. You have to write all solutions of this quadratic equation. So for that first you have to solve this one. X square minus 5x plus 6 equal to 0. This is a quadratic equation. You have to find two numbers, product equal to 6, sum equal to -5. Two numbers are, it's very simple, -2, -3. We can factorize this one into x minus 2 into, right, x minus 3 equal to 0. So solutions are 2, 3, right. So how we can represent by using roster form? We can use capital letter A, then elements 2, 3. This is unique. Now consider the third question. Set of all letters of the word mathematics. That means what all letters we are using for making the word mathematics. So we can use capital A, capital B, anything. Here I am using capital B. So now letters are M, then A, T we have to use, then H, E. Again M we cannot write. Okay. In a set we cannot write one letter two times. Actually, this meaning is what all letters we are using for making the word mathematics. Okay. Then A, you cannot write I, write I, C, S. By using these letters, we are forming the word mathematics. That is the meaning. Okay. Now, second form, that is set builder form. In set builder form, sets are represented by using a common property that is satisfied by all elements of the set. There will be a common property. By using that common property, we have to represent set. For example, suppose you want to represent all natural numbers less than 5 by using set builder form. First, I will write its Rosset form. All natural numbers less than 5 means 1, 2, 3, 4. Now, this set we want to represent by using set builder form, by using a common property. We will start like this. Same way, then x. Set of all x. We will read it as set of all x. Means this x represent all these elements. Such that set of all x, such that x belongs to n. That means x should be a natural number. One more condition should be there. X should be less than 5. X less than 5. Okay. In this way, we have to represent by using set builder form. A equal to set of all x such that x belongs to n and x less than 5. Now consider some questions. Present the following set in set builder form. Here questions are given in Rosset form. We want to convert into set builder form. So consider first question that A equal to 5, 6, 7, 8, 9. This one you have to convert into Rosset form. Actually these are natural numbers between 4 and 10. Right. So how we will represent A equal to set of all x such that x belongs to n. Means x is a natural number. It should be in between 4 and 10. So we will write like this: 4 less than x less than 10. Otherwise we can write as 5 less than or equal to x less than or equal to 9. Okay. Now consider second question. B equal to 5, 6, 7, 8, 9, etc. is there. Same elements, but it continues up to infinity. So how we will represent B equal to set of all x such that x belongs to n and x should be a natural number more than 4. There is no upper restriction, upper limit. So all natural numbers more than 4. That means 5, 6, 7, 8, 9, etc. Okay. Now third one. C equal to a set containing 2, 4, 6, 8, 10, etc. Actually these are multiple of 2 or even natural numbers. So here we have to use one formula. X equal to set of all x says that x equal to 2n. Multiple of 2 we will write 2n, right? Where n belongs to n. Okay. So first value of n is 1. When n equal to 1, this will become 2 into 1, that is 2, first element. When n equal to 2, x will be 4, 2 into 2, 4. When n equal to 3, x will be 2 into 3, 4. And then we will get all the elements. Okay. Now D. 2, 4, 6, 8, 10. Actually these are same elements, but here restriction is there. Up to 10 you have to represent. So how we will represent? D equal to set of all x says that same formula, right? X equal to 2n, but n should be less than, okay, n belongs to, okay, first we write n belongs to n should be a natural number and n less than or equal to 5, right? That restriction should be there. N less than or equal to 5 means when n equal to 1 we'll get 2, x equal to 2 into 1. When n 2 we'll get 2 into 4. When n equal to 3, we'll get 6. N equal to 4, we'll get 8. And n equal to 5, we'll get 10. We cannot take n more than 5. Okay. Now consider question number 5. A equal to 2, 4, 8, 16, 32, etc. By observing these elements, we can see that these are powers of 2. 2 raised to 1, 2. 2 raised to 2, 4. 2 raised to 3, 8. So how we can represent by using a formula? A equal to set of all x such that x equal to base is 2 for all elements. Exponential is changing. So 2 raised to n we will write. Okay. And n, what about n? 2 raised to 1, 2 raised to 2, 2 raised to 3. So n belongs to natural numbers. Okay. Now, question number 6. B equal to 2, 4, 8, 16, 32. Up to 32. There is one restriction here. Up to infinity is there. So, same formula, right? So, B equal to set of all x such that x equal to 2 raised to n belongs to n, but there should be some restriction up to 32. 32 means 2 raised to 5. So maximum value of n should be 5. So n less than or equal to 5. Otherwise n less than 6 we can write. Okay. Now consider question number 7, that is c equal to 1 by 2, 2 by 3, 3 by 4, etc. is there. So how we will represent by using a formula? So we can write like this, c equal to set of all x. Okay, so that x equal to, numerator also changing, denominator also it is changing. So write like this, n by n we cannot write because 1, 2, 2, 3 like that follows. 1 denominator is one number more than numerator. So if numerator is n, denominator should be n plus 1, right? Where n belongs to natural number. All natural number we can take. When n equal to 1, x will become 1 by 2, first element. When n equal to, x will become 2 by 3, that is second element. Similarly, we will get all the elements. Okay. So in this way, we can convert a set in Rosser form to set builder form. Okay. So in this class, we studied what is set, how to represent the set by using Rosser form, set builder form, etc. In the next class, I will teach you different type of set. Okay. So thank you.